For 8.3, we're going to start to look at confidence intervals for proportions. So this is similar to what we did with confidence intervals for means, but here we're looking at the proportion of a population versus the average or mean of a population. So we want to estimate, for example, a question like this discussion question. In a survey of U.S. adults conducted last month, what proportion of those sampled stated that their life changed in a major way as a result of COVID-19 pandemic? Right, and so we can never ask the full population. So one way we would try to answer that question is through a sample. We would do a survey, collect data, right? What do you think the percentage would be, right? What questions do you have about that question? Think about that, right? We're asking for a percentage, a proportion, right? And so we're going to ask a certain amount of people, and then we're going to get an estimate for the population. Now that estimate is our statistic, right? And that would be your p-hat, right? It's your sample proportion, right? And that p-hat stands for that sample proportion. That's your statistic. And then we would want to calculate our interval, and the way we do that is through a critical value times the standard deviation of the statistic, which again has to do with the sampling distribution, which we looked at here, right? This here is the standard deviation for the sampling distribution, or the proportion, sample proportion. So we've seen this before. We've also seen this z critical also. So that's the formula we're going to use to create a confidence interval for a proportion. So here's all the notation, right? P-hat is the number of successes divided by the sample size. This is your critical z value, which depends upon your level of confidence, okay? And then we have, which we talked about in the previous lesson, and then your standard error, right? Your standard deviation of the sampling distribution for proportions. In short, we call that the standard error for p-hat. And so we have some requirements, of course, before we can conduct a confidence interval. We have these requirements. The samples must be independent, which again, we can use the 5% rule, meaning as long as our sample is less than 5% of the population. The sample is drawn in some random method so that it's unbiased, and that the sample's large enough. And the way we do that, and we've done it before, n times p has to be greater than 10, or n times q has to be greater than 10, which really amounts to the number of successes that we see and the number of failures, right, that we see. And so that's where that formula comes from. And so we have steps to do a confidence interval, and these are the 5 steps. Right, to find the parameter, which would be a proportion. We're going to run a 1 proportion z interval test method. We check the requirements. We construct the interval using the equation that we have right here, using the formula, and then we interpret it. That's what we got.